Okay, next up we have Zico Kolter, Associate Professor in Computer Science at Carnegie Mellon. His work spans the intersection of machine learning and optimization with a focus on developing robust and rigorous methods in deep learning applied to sustainability and smart energy. Let's welcome Zico to the stage to talk about foundation models and democratization of AI.
All right, this is my, it is. Wow. I want to turn this one off maybe too. This one's off now? No. All right, it's wonderful to be here. So I'm going to talk today about AI. You're probably sick of hearing about AI, but hopefully it'll still be a fun experience for all of you. So as mentioned, I'm Zico Kolter. I'm a faculty member at Carnegie Mellon. I'm also chief scientist at AI at Bosch. So one of the great things about being faculty is you can kind of share these dual roles. And I want to talk today about some of the innovations that are driving the field right now. Because, and this was maybe a controversial statement, is this going to work? 2 years ago? Is it advancing? Am I going to have to tell you for each slide? Oh my goodness, okay. We're in the midst of an AI revolution right now. Right, this was a controversial statement, I would say like, up to, like, when I would say this a year ago, no one would really believe me. Now everyone, I think, says, yeah, duh, of course we are, right? But what's different about this, next slide, is that tools that used to require basically a PhD in computer science now are usable by everyone. Right? And that's what's amazing about this right now. So I want to ask, point to you. Next slide. What do these tools mean for the future of sensors and sensor applications? And I admit, I'm coming at this from an application standpoint. I do work actually a lot of applications of sensor devices, but I work at the getting out readings levels, not at the level of actually building the sensors themselves. And what I want to talk about today, though, is what's going on in AI right now that's making everyone kind of wake up to a certain extent. And I want to do it because you actually can describe how these things work to some degree. And what's amazing about them is not that they're complex. They're amazing because they are simple. And I think that's actually kind of what inspires me most about AI. So I want to take a little history. It's the next slide. I want to take a little history down kind of the course of AI and give a simple example here. This is about as close to sensors as I get. Baking boards and ovens. I did used to do that actually. So but that's again as detailed as I was get. But say you wanted to write a computer program that could differentiate between images of properly soldered pieces on a board and something that was just missed, right? A piece that was missed. And of course, this is just one example of visual recognition systems, image classifiers that you might want to build. There are, of course, many similar examples kind of throughout many different industries, right? So next slide. So what I want to do is I want to take you through kind of a history of how we solved this problem in AI over the course of AI. So at the beginning of AI, it was basically manual engineering by a fancier name. Right? What we would do is we would basically think real hard what makes images of PCB boards with a part in them look different from ones that are missing a part. And we would try to formulate this kind of as a program, write it down, and run that program. That was what AI was. The problem with that, of course, is that this is not very, doesn't work very well. So I'm actually a reasonably good programmer, but I couldn't do this, right? Computers don't see images. They just see a bunch of a bunch of pixel values. It's really hard to write a program that can do that for a variety of different shapes and sizes. So next slide, we sort of came to the era of machine learning, or AI 2.0. And machine learning was great. Machine learning is what I work in. Right? So machine learning, the idea of machine learning is that it is a kind of data-driven programming. Instead of manually typing your logic, you give it a bunch of examples of data, right? Good PCB boards and PCB boards missing their parts. And you let the computer figure out how to differentiate between those two things. The problem is now you've gone from, it disappeared there. Now you've gone from a case where you're basically spending all your time writing code to spending all your time collecting and labeling data. and forgetting that you forgot to include some kind of data, et cetera. Right? And so after this, I think this might be working now. Excellent. We are now in the third phase of AI. And we are reaching a point now where basically you can just tell a computer what to do, like find pictures of PCB boards with a part on them or with no part on them, and it will just do it. And I can't overemphasize the impact this is going to have on every field I can imagine. Because what used to take months and a degree in computer science now can be done by anyone in a few hours. And I'm in fact going to solve this problem in a few minutes in a second. Before I do that though, oops, okay. Now I have it here, but you can't see it now. It's better to have it there than here. Yeah, there we go, okay. All right, so the core technology that's underlying all of this is actually broader than generative AI. The core technology underlying this is actually something called foundation models. Foundation models are large pre-trained models that are trained on open world data and then specialized to an individual task through prompting or through fine-tuning. It's kind of a mouthful. Here's what I mean. In traditional machine learning, you take a lot of data, put it into a machine learning algorithm of your data of your task, put it into a machine learning algorithm. What would come out was a task-specific model that solved your task. The foundation model approach is you take the entire internet to a first approximation, feed that into a machine learning model, and what comes out is a foundation model. It's a general purpose model. Then you take a little bit of data from your task, combine this with the foundation model, and get a task-specific model that works better than anything you would have before. And so all these things like ChatGPT, all these things you've seen, they are foundation models. They are models trained on lots of data that when you ask it a question, you are specializing it to an individual problem. Okay, let's jump in a little bit and give some examples. Enough with like the high-level pitch. Let's give some examples. So I assume everyone here, by a show of hands, has everyone here used ChatGPT? Anyone not used ChatGPT yet? Okay, a few of you. So I usually say, like, go check it out, but do it after the talk. But at this point, I mean, you can open your computers right now and do it. It's pretty cool. You won't regret it if you miss this talk. Here's ChatGPT. I'm going to ask it to write a summary of the future of MEMS devices, MEMS sensors. And it will, write a nice summary of the future of MEMS sensors. And I won't go through and read all that, but it's a totally reasonable, coherent, I think, from what I know, essay on sort of the future of the field, what might be coming in the next few years. That's incredible. So how does that work? So the way ChatGPT works is ChatGPT is, again, it's a foundation model, but it's a particular instance of a foundation model known as a large language model. And what that means is when you ask a system like ChatGPT a question, what it does is it says, what is the next word that's going to come after your question? If I'm trying to sort of write more text after your question, what word should come next? Well, you asked it for a summary about the future of MEMS sensors, so probably what it'll start with is, the future of MEMS sensors, right? And so the first word is probably the. Then you just plug that word on the end of the sentence and repeat the process. The next word is probably future. And you do that enough times, and you get a nice summary of the future of MEMS sensors. So I describe that to a lot of people about how this works. And I teach courses on this, actually. And the next question I usually get is, no, wait, how does it really work, though? Because it makes no sense that this works. So really, and I say that as someone that works in this field, it makes no sense that this works, right? How on earth could predicting one word at a time write long-form, coherent, meaningful responses? But this is all there is. There's no database, there's no knowledge base, there's nothing but just word prediction with ChatGPT. That's not quite true. There's a little bit of tuning, but that's basically the fact of it. And I would argue it's actually one of the most significant, and I would say it's a scientific discovery, that this process of generating text actually works to create coherent long-form responses. It's astounding, and it's a scientific discovery on par with many scientific discoveries we've made. Now, there are some pitfalls. You've probably heard about these too, if you've heard about ChatGPT. It makes stuff up. These are called hallucinations. I asked it to write a biography of me, and it says, I was a professor at computer science in Carnegie Mellon, or just a professor of computer scientists, working in AI and robotics, that's true. Born in Brazil, 1983, that's not true. 1985, that's not true. I was not born in Brazil, 1985. Actually, my name happens to be a Brazilian soccer player I was named after, so it assumes that if my name is Zico, I must be born in Brazil, around that time where Zico was popular. It also generates data from the training set sometimes. So, there's copyright issues, right? Because it sometimes can quote stuff exactly from things it's seen before. It's also just sort of plain old data privacy, right? You're sending your data somewhere. You probably don't want to do that with sensitive data, though there are workarounds for all that now. I used to fixate a lot on these things. But what I want to say now is that these things don't matter. What you should think about is how you still make use of these systems despite all these massive issues, because as I'll keep showing you, these systems are so incredibly useful even with all these flaws. So let's go to a different example. Because again, ChatGPT is so well known here that I think it's almost passé at this point to show schools that it can do. I will come back to it in a second. I'm not beyond that. But let me show you another example. I'm actually going to solve the example I showed before of building an image classifier that can detect parts on the PCB board that have parts and the ones that don't. Here's how I do it. This is a tool we built internally at Bosch. And what you do is you sort of define your classes, right? So maybe a soldered part and a missing part, right? And what you then do is, again, you just describe your task. A microscope photo of a black or brown component soldered to a PCB board. And a missing part is something like, a microscope photo of an empty PCB board. I forget exactly how I phrased it, but an empty PCB board with exposed terminals. And it doesn't quite know what terminals are, so I actually had to do a little check and say those are silver or white regions in the photo. And now I'm actually done. If you've ever built machine learning before, you're kind of amazed at this. Basically, I can upload images now, no training, and I have a classifier, and it works for all those pictures. If you're like me and have worked ever in machine learning before, this kind of blows my mind. Because all of a sudden, all the work we did to develop classifiers and train them and test them, and you have to do some testing still, yes, but forget and then you deploy it to an API, all that kind of stuff. It can all be done, basically, by leveraging foundation models as they exist from data on the internet. And there aren't a lot of images on the internet of PCB boards. There are some, certainly, but it's not like cats and dogs, right? It's not that common. But despite that, this can still do it. And they can solve almost any task as long as you're descriptive enough about those tasks. Okay, how does this one work? It works a little different from ChatGPT, I'll admit. This is a model called CLIP. This one much less few people have heard about. But what CLIP does is CLIP takes images from the internet, takes nearby text from those images, and learns a similarity that learns to map together to images and text that are nearby. Okay? Then, when you have some class descriptions, like missing or soldered parts, you give text describing those classes. You find a new image, and you find which text description is most similar to that image. You just predict that class. It's also called sometimes zero-shot classification. And again, if you've worked in machine learning before, as I have for many years, this just turns everything upside down about what I knew about developing machine learning models. We don't have to do all this data collection. You have to do some of it, but this data collection, curation, training, at least for the application side, not for the pre-training side, but for the application side, a lot of that can be avoided by just describing problems now. And It's hard to describe this in any other way but somehow intelligent, right? A few things about language, because I am very pedantic here. You know, I am a professor, so forgive me a little bit of terminology here. A lot of terms are thrown around for this sort of coming wave, coming revolution in machine learning, or in AI broadly. So foundation models, as I mentioned, are these large-scale, pre-trained models trained on open-world data, specialized in individual tasks. Generative AI is actually a subset of foundation models. It's specifically about foundation models that generate content. They generate text, like ChatGPT. There's others that generate images. And then large language models are actually kind of straddle those. There's some large language models that are generative, some that are not generative. And the problem here is that the most commonly known system, i.e. ChatGPT, it does all those. It's a foundation model and a generative AI model and a large language model, so it's very easy to mix these things up. But there's others, like the clip one I mentioned to you, that's actually not generative. That's not creating images. That's just understanding and reading images. There's also ones called Stable Diffusion that generates images. BERT, it's actually a language model that's not generative, et cetera. So there's a whole sort of forest of different subsets here, and I think at least these terms are important to differentiate between them. Okay, so let me end with one final example, because I think that when we see tools like ChatGPT, we think too much in terms of what's possible with chatbots. We think of them in terms of sort of agents you talk with that, you know, can answer questions like that, even though answering questions is actually not what they're best at. But we think about them like that. So let me give one more example, which is an iPhone app, all right? And this iPhone is called Briefly. It's the one on the top left there. The video is kind of a little washed out. And what this app does is this app solves a problem that I encounter a lot, and I just think it highlights kind of the versatility of some of these tools. So Briefly is an app that takes news articles on the web and just summarizes them, gives me, so I don't have to read whole articles people send me, gives me a nice brief summary about them. So I'm going to take an article, it's again a little washed out there, but I'm pasting the link to the article there. It's a New York Times article, but you can actually really paste in any URL. It'll download the text, parse the text, feed the text into ChatGPT, ask for a summary of that article, and then give me a nice sort of version of the summary of that article. This one, I guess, is about researchers that care breaking things like ChatGPT. So that's really cool, right? This is like a very nice, useful tool that we didn't have before. But the real punchline is that this is not a real app. This is an app that I wrote on the plane ride here. Actually, it wasn't the plane ride here, but it was a 4-hour plane ride that I wrote from scratch using ChatGPT. All right, and what I did was I asked it, let me write an iPhone app that does all this, has these features. And it didn't just do it, by the way. It gave like stub code, but it basically gave me like an outline of the code that I just followed the instructions, copied and pasted into Xcode, and then sort of was off to the running and built that app in 4 hours. I would also have to follow up on questions. It's like, okay, now you built the basic interface. How do I add functionality? How do I actually make it work more broadly? And it would give me more code that I'd copy and paste in there. Then now, how do I set up a database, things like that. The language you use to code an iPhone is called Swift, and I don't know Swift. I've never written an iPhone app before, never coded in Swift. I know how to program, but I don't know how to program that language. The entirety of development, and this goes from application development to programming underlying sensors, is going to be transformed by this. By the way, it even came up with a name, Briefly, which is a great name for an app that summarizes news articles. Let me end with some final thoughts here. I think when we talk about AI in a domain like sensors, we often think about sort of the specialization of AI methods to things like sensor signals and stuff like this, right? That's I think, frequently how AI is thought of in these domains. But I think that with the tools that are emerging right now, this is really only ultimately a small piece of the puzzle. These new class of tools that we have, they are so broadly usable and so broadly applicable that even as what I would call kind of support functionality, they are revolutionary. As I said, I've never written an iPhone app before. I use these tools now to write all the code that I write, and I do actually still write code. In 6 months, which is when GPT-4 came out, which is what we actually need to really do this, you need the latest version of it, but it has completely transformed basically the way I work. Not through like transforming my research itself, but by transforming all the support functionality that I do kind of in my normal job. And I think that effect is primed to have massive implications on every industry we can imagine. And frankly, I don't think we've calibrated ourselves yet to a world where you can do software development that easily. I think this will change the future of software development and every sort of research field. If you can get familiar with this, it can do simulations too, it can program MATLAB, it can do whatever you want. I would encourage everyone here to think about how these tools can affect what you do in your work and what these tools can do kind of in your whole organization. So thanks very much.
Questions from the audience?
That was a great talk.
Thank you.
So I wonder, in your example of the foundational models for the image classification,
Yeah.
would you maybe end up with a different solution? Like if you were maybe energy constrained or processor constrained in some way?
Yeah.
Could you, I mean, maybe this is not optimal. This is optimal in the sense that it saves like the training time, right?
Yep.
You don't need a lot of labeled data, but maybe it's suboptimal by some other metric. And so
Yeah. So this is a great question. I think this is actually a very natural question to ask here, right? Because let me also be specific. These are massive models. These are models that run in the cloud. I mean, they can run on your laptop too. They're not that bad, and laptops are getting pretty powerful these days. They can even run on your phone sometimes, but they're not running in, an embedded device that's low power that wakes up once every hour and to run some task. One of the most interesting kind of areas of active research in foundation models right now, which we are actively working on, is how do you compress these things once you've built your specialized model to run that one task. And what I'll say is there is a lot of things you can do there in a fully automated fashion. So when you have a single application, you don't also need to recognize cats and dogs, right? That's not relevant knowledge to your task. And so there are automated ways to compress essentially these large models down to at least the size of existing architectures. Now, whether that's too big for your current application or not, that depends on your application. But this is still very much an active area of research. Yeah.
Cool. So like it's kind of a naive way of thinking about it. You could maybe truncate the model.
Exactly.
And then check like with the classification accuracy and basically keep doing that until.
Right. You kind of extract what's the knowledge. You distill down a smaller version of your model on a smaller model class for your hardware. Yeah.
All right. Thank you.
We have a question in the back.
Hello, very interesting and inspiring presentation, thanks. I'm Andrew Fung from AM Fitzgerald. It's a question about foundation models, specifically language models.
Mm-hmm.
Do they take as the input data set, does it glean stuff written in other languages?
Yeah.
So includes stuff published in whatever,
Yes,
Italian
so
and Chinese.
yeah, absolutely. So you can try this out. You can actually talk with ChatGPT in whatever language you want. It doesn't do as well as English, but it does pretty well, and it will. And so what it does is it ingests data, text, but really just sequence data from every language, right? Everything on the internet it can find, and learns to predict tokens that way. And even in doing so, learns to translate pretty well. It can actually translate pretty well just kind of as a byproduct of this. And one example you just saw is actually code. So that code it generated, it just reads code as text. and breaks it up by words somehow, and then generates code fluently inside of English descriptions as another language. And learns to correlate it with English. I mean, it's incredible. It's truly a scientific discovery that this process works. Yeah.
The impressiveness is truly amazing. I'm interested in your thoughts on how they can bind it down to truth and factuality. For example, I've seen code generated from it where it hallucinates entire libraries, non-existent functions, and you're looking at this wonderful code that if only the underlying libraries actually existed. What are your thoughts on their ability to be able to bind this down to truthful reality?
Yeah, so just like I don't live in Brazil or wasn't born in Brazil, you know, some great library for your sensor just doesn't exist, but it's going to start calling it, right? Anyway. Let me give you my take on this, which I think is maybe a bit controversial here. Because everyone's trying to get LLMs to stop hallucinating. It's like the big thing, right? It's like, oh, we have research to get them to stop hallucinating. My take is different. My take is, even though they hallucinate, they are still so useful. And when they hallucinate, it is actually the user's job to differentiate that, to understand it, and give it new context, new information, new prompting, to then get out the behavior that you want. This will become the new kind of programming. It will not be about fixing hallucinations, because those are, I mean, we're improving, but they're kind of built in. Again, there's no database, there's no code base, there's no syntax checker or compiler there. It's just text prediction. They're going to hallucinate because it could have existed, right? This library could exist. And so the thing that we will have, the skill that we need to develop as the new class of developers will be the ability to prompt them in a way that gets useful information out despite the fact that there are hallucinations. And tell it, that library doesn't exist. Here's a library that does exist. Write the functionality that you wanted to have in that library using these functions and things like that, right? Which is very doable even right now.
Let's thank Zico again.
Thank you.